So you use this place to edit the demo description, but not the code. The code should be on a GitHub repository. So there will be some IPOL specific files in the repository in addition to the code. So we strongly suggest you keep the repository private and separate from the one you use for your main code and to share it to the public. Because it will be a bit different, there will be more files that people don't need to see and that may confuse them if you show it in addition to the main repository. So also, as a note, we only support code on GitHub, not other Git repositories. So today, we will guide you to create your first demo, starting from a template with already some code, and then using your own code. The goal of the day is that at the end of the day, you have your own demo, which can run your code, not with everything, because something you will not see today, but at least that can run it without errors, even if you need to stop early, and show a few simple outputs. So first, we need to prepare your code for the demo, to put it in a Docker container so that it can be used on the IPOL control panel. Then you create the demo on the control panel, you add the code to the GitHub repository, and finally, you add the demo description to make it easy to edit it. So, the first step, for now, you can take this template. It has some code in it. It's a very simple template, which will simply take an image as input, add some noise to it, and show the image with added noise. So it's very easy and perfect to try making your first demo. So I recommend you start with a template, and then you slowly modify it to fit your own code. So, first of all, especially if it is your own code, you need to make sure it works. So, if you're taking work from other authors, first, you need to try and manage to run the code locally on your computer. If there are some errors, you will see it now. If there are some hidden requirements, now is the time to note it. So you need to understand what the requirements to run the code are. So especially the Python version, if you are using it. The packages you may require, both in terms of system packages you may need to install for more specific cases, or simply Python libraries. You need to understand what the code requires as inputs to the demo. So for instance, our demo, we take an image and add some noise. So we need an image, and there is a noise parameter to specify how much noise we want to add. Then you also need to note what outputs you want to display. So of course we want to show the main result of the demo, but in many cases there are some intermediary results that are interesting and that you want to show to the user. So here you can start thinking about what you want to show. Show enough for the user to understand the demo. Do not show too many results because the demo will then take more time and may confuse the user. So of course, it's often better to show a bit more than less, and then we can revise it later, and you will get feedback when you submit as well if something is not relevant and needs to be removed. But of course, only show relevant outputs, not all intermediary steps, because it will just confuse the user. And finally, you need to understand how to call the code from the command line. So this part is very different depending on your code. But the main idea is that you need to expose the code and expose the arguments to the method to the command line. So for instance, if it is a Python code, there might be, in our case, a parameter to add noise, but maybe it is written in the code, hard written in the code. In your case, you want the user to be able to select it. Then it means you have to expose it to the command line, so that when we call the code from the command line, we can specify it. The probably easiest way to do it in Python is to use rparse. For other languages, you have your own libraries or own methods to do it. So in this case, it's not about IPOL directly, but just thinking about the code and what you want to show to the users. So what you want them to be able to change as parameters. Sometimes some demos don't have any parameters because there's no need to change them. Some have a lot of parameters, which we don't recommend unless it is specifically needed for this demo. But in many cases, some parameters are best fixed and left hidden to the user. So they can, of course, change it if they download the source code themselves. But on the demo, you fix them once and for all. And you expose some other parameters which the user will want to control. So if we take our template as example, the requirements for the template are to use Python 3.9 and 2 different libraries here. The inputs are one image and the standard deviation of the noise to add to the image, which is a floating number with some minimal, maximum values and a default. As outputs, we show the input image, the output image, and so it's not written here, but we will also want to show the standard output of the command line. So basically what is written in text when you call it, we want to show it to the user. In most cases, I suggest you do it as well. So add what we call the standard output, std out, show it as a result. At least while you are debugging, it is often quite useful, even if you remove it at the end. And finally, we will use this command to call the code. So not here the $bin, because the code is executed from $bin. Input 0 is what is the name we give to the input. And $sigma is the name of the sigma parameters. So more on that a bit later. Here it is about the $bin, the last step of preparation to your code, which is to make sure your code can be executed from anywhere. So often when you run code from the command line, you go in the directory of the code and you call it, for instance, python main.py. But in some cases, and this is the case on IPOL, we want to be able to run it from other directories. Which means that for some Python loading files, the weights, for instance, if you load them, will not be in your current directory. Some other files you want to load that are relative to the code and in the code are not in the main directory. So you need to make them relative to the Python file, so you can use these lines. That way, in your system as well as on IPOL, you can run the code even if you are not directly in the directory of the code. So this is an important step if you want your code to run, especially if you have multiple code files or if you want to load weights, for instance, from a model. And then in IPOL, the code is located not in the root directory in which you are, but in $bin. So when you call the code here, you call it in $bin / the name of your file. So now your code is prepared. You need to containerize it. So if you already know about Docker, it's really great. It will probably help you a bit when debugging. If you do not know about it, you will now, You do not need to know everything. You don't even need to have it installed on your own computer if you don't want to or for any reason. But you need to create simply a container, a description of a container that will describe how to download or how to use the code, which parameter, which requirements it has, so libraries, Python versions, etc., and how to run it. So you start by creating a Docker file. In your code, we recommend doing it in this location. If you use the template, there is already a Docker file, you can start from it. If not, download the Docker file from the template and you will edit it. Then you will need to choose a base version of a base image for the Docker. So there are a lot of images to choose from. So for most cases, we recommend sticking to the second version, so V2 images, unless, of course, you need some earlier Python versions. So in the Docker file, you change it here on the first line. And this, in many cases, this is the only line you will actually need to change from the template we gave to you. So how to choose the image? So first of all, if you are using Octave or MATLAB, there is a specific image with Octave. If you're using MATLAB, you need the code to work with Octave. If you are using Python, then there are a lot of options. It depends on your version. So if you can use versions 9, 10, or 11 of Python, in which case you can use version 2 images. If you need to use earlier Python versions, there are some here. So for versions 7, 8, and 9, you can also use V1 images. If you need to use PyTorch for deep learning, you just add to the version a dash PyTorch to use an image which has PyTorch already installed. The same goes for TensorFlow. If you need a GPU, so only if you need it, you can add a dash GPU, either to the base image or to a PyTorch or TensorFlow image, but only with Python 3.11. Finally, if you want to use another language like C or C++, most of the base tools are installed on all of these versions, so just use any. We recommend using the most simple ones, so for instance, the Python 9 or 10 or 11 version without adding PyTorch or TensorFlow if you don't need it, of course. So these are the IPOL-based Docker images. We strongly recommend using it. It will make it easier for you because you have the templates. It will make it much easier for us to help you. But if you know what you are doing and if you really need another image, for instance, if you need to use a specific framework that is not installed here but is installed on another image, it is also possible. But only do it if you really need it because it will be a bit more difficult to do it. So a quick word on GPUs. So as you can see, we have some images with GPU support. We recommend, as long as you can, not using it for several reasons. So first of all, support for GPUs is a bit experimental. It will be harder to debug, both for you and for us to help you. Maintenance in the long run, in the long term, is a bit less guaranteed, because if the CUDA version changes, for instance, it can be harder even on Docker containers to change it in the long term. The resources on GPU are more limited. If too many people want to load a GPU demo, the demos will crash. And finally, note that IPOL is a demo system, not a computation cluster. So it's not there to run a lot of code. When possible, you should write demos that can run smoothly without a GPU in 30 seconds to 1 minute. If needed, it means you can reduce the input size, for instance, if you process images. If you have a parameter to control the quality at the cost of more expensive power, you can set a maximum quality and not go over it in the demo. The goal being that, if possible, it runs smoothly without a GPU. So now, this is just for the Docker image, the base image. Now, you may want to install some packages. So the base images we show you on the template are Debian images. So any package that can be installed with apt with apt-get on Debian, you can add it to the packages file and ask for it to be installed. So if you're creating a Python demo, in most cases you will not need any package, in which case you just have to keep the file empty, but do not delete it, because otherwise it will still try to copy it in the Docker file and fail. Do not add Python libraries here. We'll install them separately with pip. And also note, so there's a link, it's the same as earlier. A lot of packages are already installed in the base images, especially, for instance, if you're using a C or C++ demo, a lot of compilation and basic tools are already installed, so you do not need to install them again. So for reference, in the Docker file, it will be the lines 4 to 6. Basically, they will get the package list and just install them with apt-get. So you do not need to modify these lines. You just write your packages in the .ipol/packages.txt file, and here it will be managed automatically. Now, the same goes for the Python libraries. You write them in requirements.txt, so at the code root, not in the .ipol directory. Again, in the template, there is already such a file. Add any pip libraries you need to install here, one per line. If you do not need any libraries, keep the file empty. Again, do not remove it. And an important thing here, specifies the exact version you need for each library, which is very important for reproducibility purposes. It's not strictly needed, especially when debugging or creating the demo, you do not need to do it. But before submitting it, and before running your experiments, you need to specify the versions so that you know the specific versions used to run the code. Again, several basic packages are already installed, so it's in the same link. For instance, basic Python like NumPy packages are installed. If you specified you wanted a PyTorch or TensorFlow demos, the corresponding packages are also installed. If you specify them again in the Docker file, try to use the same version as in the base image, which is very useful to save storage space in the IPOL servers when saving the different images. So here in our templates, we only need 2 packages, so we just put them here. So here it will change a lot depending on your code and the requirements you need. So it's very similar to the packages for the libraries. It will be in the lines 8 to 10 in the Docker file. Then there is a lot of text in the rest of the Docker file. So I won't go in the details of what it does, but simply keep it there and don't modify it unless you know what you're doing and you really need to. Because if you modify it, what we explain now may no longer be valid. The same goes for the packages and requirements files. We specified specific locations to write it. If you modify the Docker file, you can change those locations. We recommend not doing it so that it is more uniform and much easier to help you if you need help, of course. So for now, the only line you need to change in the Docker file is the first line, actually, to choose the base image. You will need to change the Docker file later if you want to add some compilation in the file. So for instance, if you're writing a cdemo, you can write in Docker, so in the Docker file, you can write how to compile it. We will explain that in more details tomorrow. The same goes if you want to load weights for a network, you will need to download them in the Docker file. So again, tomorrow. In the meantime, try to run your demo without this. So for instance, do not load the weights, just keep random weights if you want. The goal today is just to make sure the code runs, and you will see tomorrow how to load the real weights. So now you have created your Docker file, so we can containerize the code. Then you can create the demo on the control panel. So you will go to the control panel. So here it's CP2. So just follow the URL. Use your account, as we explained to you earlier. If you want to create a demo but did not receive an account, then you just have to ask us so that we can create it for you. Once you have logged in, just click on this button to create a new demo. And you will need to indicate some information about the demo. So the last two fields are easy. The title is the title of your own demo. The state is workshop. Do not use something else for now. It is reserved for when your demo is accepted with the article and published or being published. So for now, only use workshop. As for the demo ID, you just have to go to this URL, check under workshop the first public demo, so non-private. They start with 77777 and a few zeros here. Just note the ID and add one. So here it's 77777000501. Now it will be the same but 502 at the end instead of 501. So just make sure that it follows the same leading characters, and it needs to be something that is not already taken. So here it will be 77777000502. The title, your demo, the state workshop. You click create, and you should arrive here on a big screen to edit your demo. So the DDL editor, the main part of the screen, we will fill it a bit later today. There is, so it's not in the slides, but you can click on editors. If you are working together on a demo, for instance, you click on editors. If you want to add someone to the demo so that both of you can edit it. Logs is to show some example data so that user can select it. We'll show how to use it tomorrow. And archive, you don't need it right now. It is to visualize the archive. We'll see that tomorrow. What we will need very soon is a key at the bottom, which is needed to link the demo in IPOL to the code in GitHub. So remember this button to copy the key. We will need it very soon. So now the next step is to push the code to your GitHub repository. So your code should be on a GitHub repository. As you've seen, there are some IPOL specific files. So we recommend keeping the repository private and separate from your main repository with the code. And we remind you, only GitHub is supported, not other Git repositories. So if you follow this tutorial, you started from a Git template, so your code should already be in a Git repository, so you just need to push your changes. If for some reason you did not start from the template, now is the time to push the code. And finally, once you are done, you need to enable IPOL to access the repository. So you need this step even if the repository is public. To do that, on the GitHub, so on GitHub, you click, once you're in your repository, you click on Settings, Deploy Keys, and Add Deploy Key. So here, you will have to add a new key. So as a title, you can just write IPOL, or anything you want. It is basically the key to enable IPOL to access this repository. As for the key, you go back to the control panel, you click Copy Key to get it in your clipboard, and you paste it here. You add the key here, so you click Add Key. In GitHub, normally you will be asked to authentify with two-factor authentication now, so you do it, and the key will be added to GitHub. And now IPOL, so the IPOL demo, can access your repository. A note on large files in GitHub. So you are limited to 100 megabytes per file. If you have larger files, the push you make will be rejected, and you will have to remove your commit. So that means large files cannot be put on GitHub. So if it's less than 100 megabytes, it's fine. If not, you have to upload them somewhere else. So if you need it, we can give you a link. And you will have to download them from the Docker file. So for now, don't do it. So just do not load weight if you have large files. And we will explain the details of that tomorrow. So finally, the last step is to create the DDL, so the demo description language. So here, it is a JSON file that contains all the information to run the demo and create it. So most importantly, the general information, so the name of the demo, the title, the link to the GitHub repository, the required inputs, the parameters, how to call the demo from the command line, which outputs to show to the users, and how to show the results of the experiments to all users as form of the history. So you can just take the template here. So you take it and paste it in your own demo. And now we will edit it. So it is a JSON file with several different categories. So general, build, inputs, params, web, results, and archive. General relates to title, requirements for the demo on IPOL. Build relates to how the demo is fetched from GitHub and constructed. Inputs relates to what inputs the user needs to give. So for instance, an image. Params is about the input parameters. So in the case of our template, for instance, how much noise the user wants to add to the demo. Run is a command line command you want to run to load the code. Results shows what you want to show to the user after the demo is done. And archive shows what is saved for the history. We will see that tomorrow. So today, we will show you how to make some basic editing to create a simple demo. So I will show a few more options in the slides. You do not need to pay too much attention to them right now. Focus on making a simple demo work. If you're done, you can look a bit more to see some additional possibilities. And if you don't, we will see that tomorrow morning in any case. So first of all, for the build. Oh, so the text does not appear. So here it is the demo title. So you already wrote it when creating the demo. If you go here, you can edit the demo by clicking you can edit the title by clicking edit demo. But you also have a title here. These are separate titles. One is what is written when you click the link. The other is what is shown on the demo. In practice, you can keep the same title, but you have to edit it in both places. The requirement section should just be Docker for now, so keep it as is. Unless you need to use a GPU, in which case we will show you tomorrow how to edit it. So you have to add a requirement here. The build part is about fetching the repository. So URL is a link to the Git repository. So it's usually git at github.com. And here, so instead of MLBriefs, it will be your name, so where you upload the repository. Then the name of the repository, .git. Rev shows the branch you want to use for the repository. So in most cases, for the IPOL demo, you will only have one branch. So usually origin/main, or sometimes it can be called master as well. So usually it is just that. If you want to create separate branches in Git, you can specify a specific one. And finally, Dockerfile is the location in the repository of the Docker file. So if you follow the template, it is in your repository at .ipol/dockerfile. So you do not have to change it. If you did not follow the template and wrote your Docker file somewhere else, then you have to make this part match as well. So here is for the title. You have to edit it in both places, as shown here. Now, for the inputs. So inputs are what the user can upload. For instance, an image, a text file, a video, some other data. It will be relative, so it will be placed in /workdir/exec. So you do not need to remember this, but just note that it will not be in the same directory as the code. So they will be named sequentially. If you want to access them from the command line command in1, just call them $input_0. And if you have several inputs, $input_1, $input_2, and so on, for as many inputs as there are in your demo. So there are three supported types. Images. So this is the most common type for most demos, where you upload as input an image. It can be resized if the image is too large. So we will show the details of that tomorrow. But know that the image can be processed. It can be processed to be made in 1 or 3 channels. You can specify the maximum number of pixels. If the image is too large, then it will be resized, which is very useful if you want to limit the input size to prevent the demo from being too slow. So to create an image, you have to specify image as type. you should choose an extension, so usually a PNG. It can be also a JPEG, for instance, and the image will be converted directly in the demo system to the required extension. D type is the number of channels, so 1 or 3 or 4 for if you want transparency. Here it's written X8i, so 8i means it's 8-bit, which is the only kind supported for now in IPOL. And just the X means we do not specify the number of channels, we don't need to convert it, and we will get as many channels as there are originally in the uploaded image. But you can also specify the number of channels here if you want, such as on the right, 3x8i, which means that the image will always have 3 channels. If it has only one when the user uploads it, then it will be converted with 3 channels which are the same instead of 1. And if there is a transparency channel, depending on the other settings, it will be either removed or there will be an error. So this is for images. You can also ask the user to upload videos. So I won't go into detail now because the support for video is a bit more complicated. So we will see that later. And for everything else, you use the data type. So it can be anything from a zip file to text or almost anything. You still write the extension to be what you want. So for instance, here we want a CSV file. It can be .txt if you want a text file. It can be a .zip. But the user input will not be converted to this file, to this type. It will only be renamed. So if you ask for a CSV and the user uploads a zip file, for instance, it will still be a zip file renamed as a CSV. So that means not now, but before submitting for publication, you have to put in the demo, in the code, some control, some check to make sure that the formatting of the user is correct. And in the demo, you will write some explanation about what kinds of input you expect. So the data type is very versatile because you can ask for basically anything. In many cases, it can be as simple as some zip or CSV data file. But for instance, if you want to work on a time series, but you do not know how many images are in the series, it is often much easier to ask the user to upload a zip file with all his images. So again, there is a maximum weight for the file you accept as input. If this weight is not respected by the user, so if you upload something larger, then it will be displayed an error asking for him to reduce the input size before uploading it. So this is for the input. In our template, it's the top left image. It is a simple image as input. So in your own demo, it will depend, of course, on what you want. I suggest to try with images or simple text file. If your demo requires something else, I suggest to still try with it and modify it later once you understand the globality of the demo. Also note, it is possible, as seen for instance on the right here, it is possible to display 2 inputs, so ask for the user to specify 2 inputs. So there are a lot of different options again. Some inputs can even be optional. These are more details. We will see them tomorrow on Wednesday. Then, the parameters are not uploaded by the user, but selected in the menu before running the demo. So for each parameter, there is an ID. So the ID is how you call your parameter and how you call it later when you run the demo. A type, which is the type of parameter. So it can be a selection, it can be a checkbox, a number, a slider. There are a lot of options. A label and comments, which are displayed to the user to help him understand what he should enter. For instance, here the first parameter has a label price, and the comment is how much do you want to pay for the meal. So you can check this example demo and the DDL that corresponds to it to know to access basically what is on the slide and see all the options and try them as well. So in addition to the ID, type, and label and comments, there are some values. So how you format the values depend on the type of parameters. In some cases, it's in a value field where you specify minimum, maximum, and default values. In some cases, it is the different choices, for instance here. Or in some cases, for instance, if it's a checkbox, it is just the default value, whether it is true or false at first. So there are a lot of options. For instance, selection boxes, single selection boxes, which are actually the same, just displayed differently. Checkboxes, sliders are numeric types to select a quantity. So again, the two are so here, those two are actually the same thing displayed differently. Here, you can provide the user with the option to write a short text. And there are even also options to write longer text. So there are a lot of different possibilities. Use your own judgment on what you think is best for your demo. And remember, you do not have to expose all parameters to the user. So especially at first, when debugging the demo, you can focus on just one or two parameters. And even when you publish it, not all parameters are relevant for the users. If you show that there is only one set of parameters that is good for one of the parameters, then fix it and don't let the user change it. If you really want to, but again, this is more advanced, you can hide some parameters and let the user change it only if they specify they want to check advanced options. So this we will see tomorrow, you do not need it for now. And so here's the example and the DDL. You can access them at those links. I'd like at the same time to mention there are a lot of demos already created on IPOL. You cannot edit them if they are not yours, of course, but you can access them in the control panel and see their demo description. So you can see these files for most of the created demos. So if you see a demo that does something and you want to do the same thing, you can just write the ID of the demo, look for it in the control panel, and you can see how they do it. Just be aware that some demos are ordered to this system. So especially in the general and build part, some demos do not use the new system with GitHub and Docker and maybe written differently here. But for the input run parameters part, you can keep what is here, mostly. And you can look for other demos for examples if you want. Now, you have specified what you wanted as inputs, what you wanted as parameters. Now, we can run the demo. So this is a run field, which is just actually one string. Here we call the demo with Python. So it's the line that shows how to call the demo from the command line. So here, this is a link to the code. So this is actually not for the template screenshot. In the template, it will be $bin/main.py. Remember to use the $bin/ to run the demo, which is in the $bin directory, not where the IPOL system is run. So you have to access $bin to access the demo. So this one. For the input, here it's written as input_0.png, which is fine if you specifically ask for a PNG, but otherwise you can simply use $input_0, and it will automatically fill in the extensions as well. So it is probably easier to just use this. And finally, the parameters. So you can see parameters here. So $size, $k, etc. So here it depends a lot on your demo, but the parameters are specified with the ID field in parent. So for instance, if you want to run a demo with the price as parameter, here, since the ID is price, you would call it in the run field with $price. So you have shown how to run the demo. So now the demo will run. It will give back some outputs. In our case, in the template, the outputs is the noisy image. So we took an image added noise. We return the noisy image. And we also want to show the standard text output, so stdout.txt. We also want to display it to the user. So if you run it on Python, for instance, if you do not specify a specific path for the output, so for instance, if you just save something.png, it will be saved next to the inputs, and you can access them without looking for a specific folder. So this is easy. There are different kinds of outputs. We will focus on 3 of them. The gallery output, which can be used to show one or multiple images. So one gallery can show several images. If you want to show one single image, you still use the gallery result type. You can save plain text files, so show just some text. You can also show some more complex HTML visualizations with HTML5, which can be useful, for instance, if you want to display an interactive output with some JavaScript, or simply some formatted HTML5. For instance, if you use pandas tables, you can display them quite nicely in HTML. So there are a lot of different possibilities. Some are not recommended if not needed. For instance, interactive outputs are not as practical as static ones, so we recommend only using them if they really make sense in your case. In any case, we will see that part tomorrow. And just know for tomorrow or Wednesday, there are other wizard types that can be shown. For instance, you can show types to downloads of files and so on. In our case, for instance, the gallery part, here it's the first part of the image on the left. We specify the type, which is gallery, and in contents, we write all the output images we want to show. So here, input_0.png, because we want to show the input, and output.png, because we also want to show the output. The input and output strings here are just the text that we show to the user, so the label of each image. As for the rest of the structure, just copy-paste it. But basically, you need to specify the type gallery. And in the structure you copy-paste, you have one field which is content, and in the field, for each image you want to output, you show in a string the label, then a new field inside with img and the path to the image. So, of course, it looks a bit complicated because it's a JSON file, but don't worry, you can just take it and modify it just by adding more fields as you need. The second part, in the left column here, is the std out. So here it's written on the bottom here, on the right. It is the standard output of the web. It is automatically saved in stdout.txt. You do not have to manually ask for it to be saved. But in the results, you have to ask for it to be displayed. So here the type is text file because you want to display text. Label is the label of what you will write on top of the text file. So here we just want to write output. You can write something more elaborate depending on what text you want to show. And contents, so here it is stdout.txt, which will show all the standard output of your console. We strongly recommend keeping it during debugging because it makes it easier to see potential errors. But of course, you can also specify other paths if you want to display a specific text file saved during the demo. So this is how to display gallery images. Note that there is a compare button on the right, which is very practical for the user because it means he will be able to compare any two images in the same gallery. So for instance, here, if he clicks on compare, he will see the input and the output side by side, which is very practical to see the difference. It is also possible, we will see tomorrow, to have several outputs shown next to each other in each part of the gallery. So the main case here is if you want, for instance, to display image histograms on the right of the image. It can be useful if you work on image processing. Or if you show a color mapped image. So for instance, you use a neural network that provides a continuous heat map with some nice colors. You can display at the right the color map, save it correctly, so that the user knows what each color corresponds to. Finally, there is a last part in the DDL, which is the archive. It explains what results can be displayed, or can be saved, and reconstructed later by other users. So it is not too difficult, but you do not need it to create your demo. We will not show it today. We will leave it for the following days. Right now, what we would like for you to do is first of all to make sure your code can be executed. You will need it for the one part. So remember to use the $bin when you curl the code. Remember to change the code so that it can be, so that if you load files, you load them from the path of the file, of the Python file. Otherwise, it will look not where the Python file is and probably your file, but where the system is right now, which is a totally different place in IPOL. If you want to check it works, just try to run the code look on your computer, but from another directory. If it does not work, then it means it is not done yet. So why is it here? Okay. So now for the demo creation process. So now you should have enough to make a basic demo. You do not have all the details. You don't know yet how to add all the bears and whistles with the different parameters, output types, or the details of the inputs. But you should already be able to create something basic enough to run your code. So once you're done saving the DDL, well, writing it, don't forget to save it on the bottom left. So yeah, don't forget to save it. And once you're done, you can click on Open Demo, and it will show the demo. Once you click here, it will direct you to the demo web page, where you can test your demo, explore it. So now, in the demo creation process, we've explained most of these steps. So first of all, making sure the code works locally, creating the demo on the control panel and a Git repository, which you make accessible from the control panel. Uploading large files somewhere else, we will show that to you tomorrow, because then you need to fetch them from the local file. And now you just need to, once you're done here, you need to iterate. So probably not everything will work on the first try. You might need to change something in the Docker file or to the code. So you update it, you commit it to the Git repository and push it. You might need to update the DDL, so the demo description. You may want to add example inputs so that the user does not have to upload his own data. But if you just want to try the demo, he can click on an example input, while still being able to upload his own data if he wants, of course. So that part, we show that tomorrow. And you can test the demo. So you will need to iterate, especially on the last two parts, on the last two lines. So you test the demo, you notice what does not work, you modify it, you test until it works. I strongly suggest you start working with a template. You start working not with your own code, but with the code in the template. That way, it is exactly as in the tutorial, and it should already work well. You just have to copy-paste the DDL, which will not be copy-pasted from you. And first, make the template work on your own demo. Then, slowly, change the code in the template to match your code. Change the input, change the requirements, the Docker file if you need to, so the base image. Change the outputs you want to display, and try to make the demo run with your own code. You do not need to create a full demo right now. You do not have all the information on the results and parameters to do everything. But try to make it simple. Take an input if needed. If not, you can leave the input field empty. Choose one or two parameters in your code to expose them to the user and make them customizable. For some things, you might need to use dummy, for instance, dummy weight. So if you have large files for your weight, you do not yet know how to run it, how to upload them, and how to load them from the Docker file. So for now, you comment the weight loading part, and you just use a random weight of initialization, just to make sure the code runs without errors. So this is your goal for today. Have a demo with a code that runs without error. Show some dummy output. So actually the standard output, which is saved by default to stdout.txt. If you want, you can display some images output if your demo is suited for it. We will show how to display more complex results than just text and images tomorrow. And most probably, there will be some things that do not work on your first try, especially in the requirements or in the code location, the use of the $bin, the location of external files. Especially if you have several files, several code files, you might need some tinkering if you use Python to make them stick together and load the correct file, even if you do not run from the main directory. So this is standard Python, of course, but you might need to modify it, especially if you take code from GitHub, because in many cases, public repositories do not have all the correct code to run it locally easily. So yes, if you manage to get your simple demo working, it will be very nice, and you will be ready for the next tutorial tomorrow on more demos. So most of your time today will be spent doing that. And if you haven't done so already, to make the code you have run locally. So locally from another directory, and even before that, to make it run at all locally. If it's not your code, chances are there are things you need to modify before it runs. Either requirements or similar things. So now it will be time for questions. After that, so in case there are a lot of questions, we have some advance. But in half an hour, we will have lunch in the hall Eminateur. And this afternoon, we will be in the workshop rooms. So the room numbers are on the website, and most importantly, we will get you there. You will work together. So 3 words of advice. First of all, most DDRs are public, as I said. Feel free to look at them, look at what is there. If you see a demo with something you like, you can take it from the DDL and paste it and adapt it to your needs. Do not work alone, especially if you are new to IPOL. More than half people in this workshop have already created demos at previous editions or for other occasions. So this means that you are not, well, there are always people who know how to create demos with more or less expertise. But if you have a question, most probably someone can answer it. So really don't be afraid to ask questions, ask for help. So you can ask us for help and we will try to provide it. In most cases, it can be simple things about IPOL. In other cases, we need to investigate a bit your code. But really, don't be afraid to ask for help. So now will be time for questions. Does anyone have any questions?
Is the paper submission, is the paper and the demo the same thing for IPOL?
So I will repeat your question for people on Zoom. I am not sure we can hear the audience well, actually. So you asked if the demo and the submission are the same thing. So they are separate. For now, in the workshop, we want you to create your demo first, because for the article, you will need less help. So you can do it in autonomy. If you finish your demo, it is really nice, and we encourage you to start working on the article this week as well, especially because on Thursday, Pablo Musée will give a tutorial to write articles, so specifically for IPOL, so make use of it. The submission is not during the workshop. You have a lot of work to create your demo. Then there is a lot of work to create the article. Especially if you're new to IPOL, you will not finish both during the workshop. So we will give you some more time. We will give you some more time to finish creating and refining the demo, to thoroughly write and revise the article, because you will need to write it, to polish it, to read it, to have it proofread by other people. So, for instance, for PhD students, you will need to work it out with your supervisors to make a really good paper. before submission. So you cannot do all of that during this week. And then, so we will explain the details of submission on Thursday, but we will review at least 1 month to finish the demo, finish the article, revise it as much as you need to, and then submit a good version without being in a hurry. So, as for the submission, it will be the demo, the code, and the article, all three together. So, earlier today, I explained the different tracks of submission. For the IPOL track, the code will be peer-reviewed. So the contribution to in the submission is both the demo, the article, and the code. For MLBriefs track paper, the code is not peer-reviewed, so it is not per se a contribution. The contributions are thus the article and the demo. Keep in mind that even if you create a nice demo, we expect good contributions in the article as well, with the demo being here to complement the article and make it easier to follow and experiment. So you will need to work on both, not just on the demo. We encourage you, of course, to start working on the demo because we are here to help you, but you will need really both parts to publish your article, plus the code if you want to submit in the IPOL track to peer review it. Did that answer your question? We have any other question? And if not, does someone here want to add something about IPOL or technicalities? No? Well, if not, we can conclude for now. So thank you for attending. We will have lunch very soon, in a bit less than 20 minutes. So in the meantime, feel free to visit the garden, which is very nice. And otherwise, we will also show you to the dining hall when we can meet in 20 minutes. Thank you.